just remember the way that things are asked. There's a lot of line segments in this example. So this example is actually more for line segments. And we see that we could be told in an indirect way what the x coordinate actually is. I'm just using this image. So let's quickly see what our a and b coordinates are. We have a function f of x. And we know that we can solve f of x, making it equal to 0, which will allow us to get coordinates A and coordinates B. That's all I'm interested in for now, for the purpose of explaining your average gradient. So what I'm going to do here is I'm going to say f of x is equal to 0. So 0 is, oh, this is too thick. 0 is equal to, and I will solve x squared plus 3x minus 4 and factorize. I have a positive 3 in the middle, so it's a plus 4 and a minus 1. Therefore, x is equal to minus 4 or x is equal to 1. So at A, I have a coordinate of minus 4 and 0. And at B, I have a coordinate of 1 and 0. Right, so there's my B. That's at 1. And here's my A. And that's at negative 4. So what do we see now is that when we are asked the average gradient, we might not be given the coordinate at that point. I've merely solved it so that I do know what it is right now, but the process of first finding the coordinate could have been part of your answer for something like a question asking you to find your average gradient find the average gradient between A and B. Okay, which now makes it clear why I had to get the x coordinates at A and at B, because I did not have them. So you would first have to solve to get the values. At A, x is 4, minus 4, sorry. At B, x is 1. And now we can continue and we can see, great, let me find out what is my f of x, what is my value of y. When x is minus 4, I can see it's 0. And what is my value at f of 1? If we were asked a little bit more advanced in this case, we could have said, let's put the coordinate here. And let's mark that spot with x, for example, and say, let's find the average gradient between A and x. So that in itself is on the straight line that's been given to us. And you can see from that straight line, the g of x line, it actually is really a gradient of 1. From just looking at the gradient, g of x is equal to x plus 4. So just beware, if we are asked, perhaps, what is the average gradient? Find the average gradient between x at A and E. Then we would have to find the coordinate at E, but E again lies on my straight line. So the gradient of this line is already 1 from what's been given. So it all depends on what information we have. If we are asked, find the average gradient between A and B, let me go back to this one, the first one. find my average gradient between A and B. If A, O, let's add something there. Find the average gradient between A and B. If AO or OA is equal to 4, then what would this mean? If OA is equal to 4, they're in fact telling us, let's highlight this then, OA equal to 4 means that they're telling us the units from the origin to the letter A is in fact 4. Then you should watch out not to use a positive 4 for your X value, but to interpret it as O. That means, therefore, at coordinate A, I'm at -4 and 0. And from that deduction, carry on with your working. So this is a nice example where we can kind of test the range of how that question could be asked, depending on what has been given, depending on how much work needed to be done in order to get the answer at that point. Okay, so like I said in the beginning, it's a very, very nice example here that pertains to lengths as such, which we will do in our next lesson, which refers to your top graph minus your bottom graph. But when we are asked to work out your average gradient, we will always use our average gradient formula, where we have the difference in the y coordinate at the given x values over the difference of the given x values. I encourage you to choose set 1 and set 2. Right, let me just give you one last example here. Let's just make this straight line here. Great. There's a tangent to the curve. And what we see here is that we could ask, give me the average gradient between the symmetry axes of f of x and b. Let me write that question down. Average gradient between the symmetry axes of f of x and b. Right. That means we need to do a little bit of work with regards to finding this value. We must remember in parabolas, another name for the x coordinate at the turning point is in fact the equation of the symmetry line, symmetry axes of your parabola. The parabola is the only graph that has a symmetry axis that works like this. Therefore, it is the turning point using x is equal to minus b over 2a. We already have f of x in this case. F of x is x squared plus 3x minus 4 That means that the turning point would be minus 3 over 2. Therefore, x is equal to a negative 3 over 2. But what I also need there is my y coordinate, because in this case, I need f of that value. And that's why I'll go one step further, sub it back in and get the y coordinate, which is in fact going to be the corresponding coordinate and also called the minimum turning point, the minimum value for the turning point at the turning point. Therefore, f of -3/2 is the y value at that turning point. Subbing it back in, and finding that we here will have the y coordinate at this point. Okay, let me work that out quickly just to be accurate. Okay, we've got 9/4 minus 9/2 minus 4 gives me a turning point of negative 25/4, which is what I have when the parabola is turning and the y coordinate is negative, right? So let's continue and finish up our question. So we see here our average gradient now will occur between f of what is my second coordinate, would be the coordinate at B, which I've already worked out, is f of 1 minus f of where x is -3/2 because it's set between the symmetry axes over 1 minus -3/2. Watch out for the signs. Average gradient is in fact f of 1, which gives me a value of 0, minus f of -3/2, which is the turning point, the y coordinate at the turning point, over 1 plus 3/2. And we can finish this off by seeing that we will get a positive gradient. Let's quickly see what we get. We have a positive 25/4 divided by 1 and 3/2, which gives us 2.5. Because 1 and that 3/2. 3/2 is 1.5. 2.5 altogether gives me a beautiful 5/2 gradient, which is positive, which I can see here on my line. I then have a positive gradient between the axis of symmetry and the coordinate of B. Here would have been my axis of symmetry. That's where x is -3/2. There's my origin. And here is B, where x is 1. Positive gradient, average gradient, positive average gradient of 5/2.